On behalf of Indira Gandhi National Open University, we are welcoming you for this lecture sessions. Today's topic is production planning and scheduling. I am Subhasis Manji, professor in Mechanical Engineering of School of Engineering and Technology of Indira Gandhi National Open University. Today's topic is production planning and scheduling. This topic is from the management course MS 53, and this topic is also from ACPDM program, that is Advanced Certificate in Power Distribution Management, and this topic is also there the course Power Distribution Management, course code is BEE 003. Production planning and scheduling is absolutely necessary for smooth conduction of different activities in any organizations, whether it is manufacturing process or hospitals or in any educational institutes. See, the production manager will make planning, and as per planning, scheduling is to be conducted so that the resources available in that division can be optimally used. Now, what are the resources? The resources are maybe in terms of man, machines, materials. So, we have to make the schedule in such a way that we can carry out different activities of the department within the available resources. So, machines have to be properly utilized. The maintenance jobs have to be carried out in such a way that the machines in the production departments are always available for their works. In hospitals, the planning and scheduling may be carried out in such a way that the number of patients, whether they are required for any surgery, the equipments are to be available, the nurses should be available, and the doctors who will carry out different operations are also to be available. So, we have to make the proper planning and scheduling. Some management experts says that we have to, if we fail to plan, that means we are planning to fail. So, planning is absolutely necessary, and this is one of the most important aspects in management. Planning, organizing, controlling and leading, these are the very important aspects of management. So, today's topic is production planning and scheduling. Scheduling, establishing the timing of the usage of equipment, facilities and human activities in an organization. So, scheduling are to be carried out in such a way that we can make use effectively the available equipments, facilities and human resources for carry out different activities in that organizations or in the department, so that we can fulfill the desired goal of that particular organizations. Whether they are manufacturing units or the service centers, scheduling is absolutely necessary. Say for example, in educational institute, if they are planning for conducting the entrance test examinations, so they have to make the schedule in such a way that at a proper time the question papers are to be set, the question papers are to be moderated, different centers are to be fixed. So, lot of activities are there. So, in that case, scheduling plays a very vital role so that we can optimally use the available facilities and equipments and the human resources available for that particular organizations. Now, you see, this is one example how the resources are available. You see that in the workload manager, he might be having the processor 1, processor 2 and processor 3. So here you see that processor 2 is overlapping in processor 1 and processor 3. So we call it the shared processors, and job 1, the activities A1, A2 are to be carried out in processor 1, and the last part of the activities for job 1 has to be completed in processor 2. Now for job 2 task, that first part has to be carried out at processor 2 and the next part must be completed at processor 3. So these are the activities, sometimes they are overlapped. So planning and scheduling plays a very important role so that the work for different activities are to be synchronized for optimal output or optimal utilizations of the resources available in that particular organizations. Now we see that planning and schedule, it is not a one person's job, that lot of persons are to be involved. Say for example, there are different departments or they are in an organizations like manufacturing unit and productions unit and marketing divisions and sales divisions, purchase divisions. Suppose the marketing divisions, they plan for selling some products to the customers, and they marketing divisions, they expect that this many number of products has to be produced by the production department. So if the production department is not supplying the final products which are to be sold to the customers, definitely if they cannot produce the number of products in time and to hand over those products to the marketing or sales or marketing divisions, so marketing divisions will not be able to fulfill the customers' demand, and definitely they will not be able to satisfy the customers, and there may be a conflicting situations. So lot of activities are there and lot of parts, several persons are to be involved for planning and scheduling processes, because some jobs are interrelated. See, in Navy or in Air Force also, to fulfill the mission of any activities, so planning is absolutely required, and as per that planning, schedulings are to be made for different activities. So this is one simple diagram so that you can understand why it is so important in all organizations, whether it is in service sectors or for production unit. Now scheduling manufacturing operations. Scheduling in high volume systems requires that process and product design, very important for that. Preventive maintenance plays a vital role, because preventive maintenance are to be carried out on a regular basis for different equipments, so that the different equipments are available for the manufacturing processes, and there should not be any downtime or failure of the equipment while the process is on. Rapid repair when breakdown occur, it is expected that if there is any breakdown occurs for any equipment, it has to be repaired immediately so that the operation may continue immediately. Optimal product mixes, minimizations of quality problems, and reliability and timing of supplies. This is also very important because system has to be reliable. Now scheduling in lower volume systems, it requires loading, Gantt charts, assignment methods of linear programming, and these are the standard techniques. But today we will discuss the schedulings of a very important cases like n number of jobs are to be assigned, n number of machines, so that we can optimally carry out all the jobs within a limited resources, or we have to optimize cost wise also. Now this is one method, we call it Hungarian method, and you see that there are 4 jobs are there: job 1, job 2, job 3, job 4, and these jobs are to be carried out any of these 4 machines, that is A, machine B, machine C, machine D. Now if the job 1 is to be carried out at machine B, the cost is 8 unit, and the job 1, if it is to be carried out at machine B, then the cost is 6. So any job can be carried out, can be performed by any of the machines, and for each machines and for a particular job, the cost, fixed cost is involved. So we have to assign the jobs in 4 machines, then we have to complete all the jobs in 4 available machines, so that the cost has to be minimum. Now you think that this is a very simple problem, but if you have 4 jobs are to be carried out any of the 4 machines, the total number of combinations will be factorial 4, that is 4 into 3 into 2, that is 24 options are there. So if the 5 jobs and 5 machines are there, then 120 options will be there. If there are 6 jobs and 6 machines, then 720 options will be there. So the number of options will be very high, and for each an options will give you different cost. But the Hungarian method will give you very quickly the optimal solutions. So let us first discuss what is Hungarian method. First of all, you see that for each row, the costs are given. Say for example, job number 1, cost 8 is given for machine A, for machine B 6. So we have to see what is the minimum cost in each row. Then we will have a separate tables after finding out the minimum cost in each row. So let us see that what table we will get for this. So we have got the row minimum for all rows. So 2 is the minimum for row 2, row 1, and 6 is the minimum cost for row 2, and 3 is the minimum cost for row 3, and so on. Now similar operations we have to do for column, but before that we have to subtract the minimum for a particular row from each element in that particular row. So for example, for row 1 we have to carry out the operations like 8 minus 2, 6 minus 2, 2 minus 2, 4 minus 2. Obviously at least one case you will get the value 0. Now after these operations you will get this table, that deducting the minimum value in a particular row from the cost given in that particular row for different, say, machines for a particular job. So this value we have got, this table we have got. After that what we have to do, second method as second step, that for each and every column we have to find out what is the minimum value it is given for a column. Say for example, column A is 0, obviously column minimum for column A will be 0, same thing for B, the minimum value is 1, so we have find out the value column minimum 1, and for C it is 0, and for D it is 2. Now we have to deduct the minimum, that column, from each of the values given in that particular column. So for if we have got 0, then 6 minus 0 is 6, and the same value we will get. So for column Q we have to perform 4 minus 1, 1 minus 1, 2 minus 1, and 5 minus 1, and so on. After deducting this we will get a next table. So what is the table? This is the table we have got after deducting the minimum value for a particular column from the values in that particular column only. Now you see that here you are observing some zeros. So in first row there are 2 zeros, in second row there are again 2 zeros, and third row there is 1 0, and on the fourth row there there is 1 0. Now what you have to do, you have to cross out those zeros by drawing some lines. So if you draw a line on the first row, then 2 zeros will be cut. Again, if you make another line in second row, again 2 zeros will be crossed. Now if you make a vertical line on the first column, that is at A, again 2 zeros will be cut by that line. So in that case, what we are getting that in the next table, you see that after crossing after putting the 3 lines, all zeros are cut. Now what you are getting? We are getting uncut numbers are 1 4 1 4 7 and 2. So in this case, you see what is the minimum value out of this. So minimum values are given, minimum value is 1. So we have to deduct this 1 from each and every uncut numbers. So the 6 numbers, 1 minus 1, 4 minus 1, 1 minus 1, like that we have to deduct that minimum value, that is 1 from each of the uncrossed number. After that, you see that what are the numbers which are crossed by the 2 lines. You see that 6 is cut by horizontal line as well as the vertical line, which we are using for cutting the zeros. Again, for 0, which is just below after 6, that is also cut by 2 lines. So we have to add 6 plus 1 and 0 plus 1. So we will get to next table. So then in next tables we are getting after that. So the new table you will get. After that, again we have to do the same operations, that we have to draw the line in such a way that all zeros will be cut. So here what we have done it, 2 vertical lines we have drawn from machine A column, machine B column, and 2 horizontal lines we have drawn for row 1 and row 3. Now you see that all the zeros are cut by the lines. So how many lines we have got? We require 4 lines, 2 horizontal and 2 vertical lines to cross all the zeros, to cut all the zeros. Now this is the positions we have got the optimal solution. Now my dear friend, how to get the optimal solutions? You see the rows, that in which row you are getting 2 zeros, in which rows you are getting only 1 0. See, in row 1 there are 2 zeros at the below C and below D. So we will not concentrate on the row 1, but in row 2, just see, we are getting only 1 0. So here these 0 corresponding to the second row and second column. So job 2 will be assigned to B. Now again, if you move to the lower downward directions, you will see that at row 3 there are 3 zeros. So that is not the optimal solution. Last row, first column, that is corresponding to job 4 and machine A. So job 4 is assigned to machine A. So machine A and machine B are already allotted. Now the rest is C and D machines, and for then again we have to perform the same way. You move from top, that is first row. Here you are seeing that there are 2 zeros. 1 0 is below C and another 0 is below D. So it is not the optimal solution, and you see that you move to the next row, that there is no 0 left, and in third row you see that A and B already allocated. So the left out is CD, but C is given for that job 3 is 3 and D is 0. So only 1 0 is there left out in the job, that is the row 3. So job row, that 0 is for job 3 and machine D. So 3 is allocated to machine D, and what is left out? Left out is job 1, and that has to be assigned to the last machine, that is C. So this is the optimal solution, and job 2 is assigned to B, job 4 is assigned to A, job 3 is assigned to D, and job 1 is assigned to C. Now come to this, the table, where here you see that job C is assigned, job 1 is assigned to C, the cost is ₹2, and job 2 is assigned to B, machine B, cost is 7 unit, and job 3 is assigned to machine D, so cost is 4, cost is 6, and job 4 is assigned to machine A and cost is 5, so total cost will be ₹20. So you see that there are 4 machines, 4 jobs, and number of options will be factorial 4, that is 24, but here just after few steps we are getting the optimal solutions. So this solution is feasible if there are n number of machines are available for n number of jobs. Now we will move to another sequencing problem, that is n number of jobs are there and 1 machines are available. So for that sequencing problem, how we can perform? This is a very interesting problem. There are several say ways we can do it, and we will see that how we can do it in different ways for this sequencing problem, where n number of jobs are there, but only we have to perform all the jobs in one work center. So sequencing means determining the order in which jobs at the work center will be proceed. What is workstation? An area where one person works, usually with special equipment on a specialized job. That means only one person is there with a specialized equipment, and that equipment is for performing multitask, and so that n number of different jobs can be performed in that particular machines. That is one work center. So priority rules, simple heuristics used to select the order in which jobs will be processed. Now what is job time? The time needed for setup and processing of a particular job. That is the definitions of a job time, that how much time is actually should be allocated for that particular job if it immediately to start. Now job flow time, this is the length of time a job is in the shop or work center. So if the processing that time is 4, that doesn't mean that that job will be completed within 4 say unit time. So we will see while discussing the numericals that how it will vary. So now the total job flow time that we can calculate starting from the first job and ending to the last job, that is the total time, that is known as the job flow time. And if you calculate the job flow time for all the jobs in a workstation, we can calculate the average job flow time, and job lateness is the length of time the job completion date is expected to exceed the date of the job which was due or promised to a customer. Suppose if you promise to a customer that the job will be completed after 10 days, but it is completed within 8 days. So there is no late for completion of the job. So customer will be definitely happy because they will get the job within the pre-assigned time. But if you promise to the customers that job will be completed after 10 days, but you are delivering that job after say 14 days, so then there is obviously a late for that particular job for 4 days. So that is a job lateness. In fact, job lateness is calculated in this way, that delivery date, that due date minus delivery date. If it comes, say, positive, then we have to, then there is no late, so late is 0 in that case. Or if the job is to be completed after 10 days and you are delivering the particular job after, say, 14 days, in that case the late is 4 days. And if you are promising the job after 10 days but you are delivering the job after, say, 8 days, so in that case you are delivering before time, so late is 0. So let us see how we can solve these problems. Well, then one very important thing is this make span. So total time needed to complete a group of jobs from the beginning of the first job to the completion of the last job. So average number of jobs can be calculated if you calculate it, with the help of total flow time and make span. So average number of jobs at the workstation is equal to total flow time divided by make span. Now let us see how we can perform the jobs. So let us do this problem. That problem is given like this: processing time including setup times and due dates for 6 jobs waiting to be processed at a workstation, work center are given in the following table. Determine the sequence of jobs, the average flow time, average job lateness and average number of jobs at the work center for each of these rules. FCFS, that means first come first served. So sometimes the jobs have to be completed on first come first served basis, because if you go to any restaurant and the restaurant, you have to after paying the bill in advance, you have to deposit the slip, and the restaurant people will supply the goods on first come first served basis. But in manufacturing unit or production unit, that we may have some other options like SPT, that is shortest processing time, that which jobs takes very less time, we have to consider accordingly. D means due date, on consideration from due date, or SHEAR means critical ratio. We have to divide due date divided by processing time, we will get that critical ratio. On that basis we have to sequence. Now first let us start with FCFS, that is first come first served basis. Here there are 6 jobs, job A, B, C, D, E, F. If the job A immediately starts, processing time days is 2, and for job B processing time 8 days, job C processing time is 4 days, job D processing time 10 days, job E processing time is 5 days, and job F processing time is 12 days. Now due date for job is given 7 days, due date for job B is given 16 days, due date for job C is given 4 days, due date for job D is given 17 days, due date for E is given as 15 days, due date for F is given as 18 days. Now you see, for all the jobs, the due dates are given in such a way that if you consider job A to start immediately, then after 2 days you can complete the job, but it is ahead of the due date. Now let us see that how we can perform the sequencing if you do it on the basis of FCF, the first come first served basis. So this is the first come first served basis, that means first job is A, then next job is B, then C, then D, then E, then F. We are not considering on due date or processing time. Just as soon as the sequence comes, immediately we will start. Now processing, so flow time for A is 2 and flow time for B is 10. Why it is so? Because first the job A has to be completed. It will take 2 days, only then the job B can start. But job B can start after 2 days, but processing time for job B is 8. So total time job B will be on the shop floor is 10. So 10 days is the flow time. Now after 10 days job C can start. So job C will be completed after 14 days. So 14 days is the flow time for job C. So after 14 days, job D can start. So then that means job D will take 24 days and job to stay in the workstations for completion of that particular job. So like that we can calculate the flow time for each and every job, and if you calculate all the flow time, the total flow time will be 120. Due date is given. Now you see that the job A is completed in 2 days and due date is given 7, so there is no days, so days late, so there is no late for that, so 0. So job B is completed within 10 days but due date is given 16, so late is 0. But job C, due date is given 4 but you are completing that particular job after 14 days, so there is a 10 days late for C, same thing, 7 days late for D, 14 days late for E, and for F, the F will be completed after 41 days and the due date is 18, so late is 23, so total late for all the jobs is 54. Now we can calculate very easily. Average flow time is total flow time divided by number of jobs, that is 20 days. Average job lateness 54 divided by 6, 9 days. Average number of jobs at the work center is 120 by 41, that is 2.93. Now my dear friend, we will start the SPT rules. SPT rules means shortest processing time. You see that A, it takes only 2, so A has to be immediately start, that is the shortest processing time out of the 6 jobs. After that next comes C, because C's processing time is 4, so we have to start C just after completion of the job A. After that the next shortest processing time is 5, that is for E. Next processing time, shortest processing time is B, that is 8. Next shortest processing time is for D, and next lastly the job we have to start, because it is the maximum processing time we have to start. We have to do the job at the last. So flow time, we know that how to calculate the flow time. Flow time for A is 2, flow time for C is 6, because 4 is the processing time. It can only start after the completion of the job A, which is to be completed after 2 days. So we can calculate flow time for each. We can calculate the total flow time, that is 108, and mix span time, that is 41, and due date, if you consider that the due date for A there is no late, that is 0 late, and for the job C the flow time is 6 but due date is 4, so 2 days late. But for E, due date is given 15 but it will be ready after 11 days, so 4 days ahead it is completed, so days late is 0. Same thing, I mean, for if you calculate for B, the late is 3. If you calculate for job D, the late is 12, and the last job the late is 23. The total late for all the jobs is 40. Now there is no problem for calculating average flow time, that is 108 by 6, that is 18 days. Average job lateness 40 divided by 6, and average number of jobs at the work center is 2.63. Now this is the third way of scheduling, that is using the earlier due date. So earlier due date is for job C, that is 4, then 7 is the due date is given for job A, and next due date is 15 for job E, and next due date is 16 for job B, and the next due date is 17, that is higher than B, that is D, and last one is F, that is given as 18 due days. That means after within 18 days you can deliver that goods. So the sequence for this method, if you consider the due date as a criteria for making the scheduling for all the 6 jobs, that is C, A, E, B, D, F, C has to be fast. If C has to be completed in fast operations, the next is A, E, like that. We can calculate the flow time, that is 110. We can calculate the late number of late days, that is 38, and of course the mix span will be 41 for each sequence. Now here you calculate the average flow time, that is total flow time divided by number of jobs. It comes out to be 18.33 days, and next one is average job lateness. The total job late days is 38 divided, and if you want to calculate the average job lateness, that is 38 by 6, that is 6.33 days, and average number of jobs at work schedule, that is 110 divided by max span, that is 41. So 110 divided by 41 is equal to 2.68. Now the last criteria is using the critical ratio. See, critical ratio, you have to divide the due date by the processing time. So here for C, that is due date is given as 4 divided by processing time 4, it is comes out to be 1.0. For F, the due date is given 18 and processing time is 12, that is 1.5, next higher critical ratio. And for D, it is the due date is given as 17 divided by processing time 10, next higher up is 1.7 critical ratio. For B, the due date given as 16 divided by processing time 8, that next higher critical ratio 2.0. And for E, we are getting 15 is the due date, processing time is 5, so 15 divided by 5 is 3.0, and A is 7 is the due date and processing time is Q, 7 divided by 2 is 3.5. So we have to sequence on the basis of critical ratio. When the critical ratio is the lowest, we have to assign that job first. So C is the first job, next job is the next higher value of critical ratio, that is 1.5, next job is F, then next higher of critical ratio is 1.7, that is D, the next higher critical ratio is 2.0, that is for job B. So the next sequence, it will come the next B, then the fifth job, that is the fifth positions of the critical ratio, that is 3.0, that is greater than 2.0, so that E job will come after B. And the last job, the critical ratio is maximum, that is 3.5, so critical ratio is maximum, so we have to assign the job at the last position. So we have got the sequence on the basis of critical ratio, that is C, F, D, B, E, A. Now there is no problem for calculating the average flow time, average job lateness, and the number of jobs in the workstation. So we have calculated the flow time. So C will be completed after 4 days, F will be completed after 16 days, because the processing time for F is 12 days, but that can only start after completion of the job C, that is 4 days. So job F will be on the shop floor till 16 days, so 16 days will be flow time for the job F. For D, the flow time is 26, and job B, even the processing time is only 8 days, but it has to be completed after completion of the job D, that is after 26 days, so the flow time for job B will be 24. But see the last job, that is A, it has assigned in the last. Since the processing time is only 2 days, but it has to be completed after completion of the job E, that is after 39 days. So the flow time for job A is maximum, that is 41. So we can calculate the total flow time, that will give it comes out to be 160, and we can calculate the number of job late days. But you see that for job C, the due date is 4 and it has completed within 4 days. I mean on just after 4 days. So there is no late for that job C. So 0 is days late. So for F, the due date is 18. It has completed on 16 days. So there is no late. It is 0 late. But for job D, due date was 17, but it has completed after 26. There is a late for 9 days. For job B, the due date is given 16 days and it has completed after 34 days. So late is 18 days, and for job E, the due date was given 15 days and it is completed in 39 days. So late is 24 and for job A, the due date was given 7 days, but processing time is only 2, but it was to start after 39 days, so that's why flow time for job A is 41 days. So 41 minus 7 is 34 is the late days for job A. So total days late is 85. Now you see that we can calculate the average flow time, that is 160 by 6, that is 26.67 days. Average job lateness for 85 divided by 6, 14.17 days, and average number of jobs at the work center, that is 160 by 49, that is 3.90. So we have discussed FCFS scheduling method, that is first come first served criterion. We have discussed about SPT criterion, that is shortest jobs can be scheduled on the basis of shortest processing time, that we call SPT criterion. And the third one we have discussed on the basis of job due dates. So in that way we can sequence the jobs. And lastly we have considered the jobs sequencing for critical ratio. Now you compare all the results in a tabular form, then you can compare which method is good and which method is suitable for about different criterion. So this is the comparison table. So FCFS means first come first served, SPT means shortest processing time, DD means due date, and CR means critical ratio. So if you see the average flow time, that is first come first served basis, average flow time is 20. Average flow time for SPT, that is shortest processing time, is 18.00. Due date average processing time is 18.33, and for critical ratio the average flow time is 26.67. Now you see, if you consider average flow time for FCFS, it is 20.00. Average flow time for SPT sequence, that is shortest processing time, that is 18.00, and the average flow time for DD, that is due date, it comes out to be 18.33, and average flow time for critical ratio, it is 26.67. From this column you see that which method gives you the best output. If you can consider average flow time, obviously the 18 is the minimum, so SPT sequence, that shortest processing time, is the best one. Now you see the average lateness, that if you perform on the basis of FCFS, the average lateness is 9. If you consider SPT sequence, the average lateness is 6.67. If you consider on the basis of due date, the average lateness in days is 6.33 days, and if you consider the sequence on the basis of critical ratio, the average lateness is 14.17. Now you see which one is the best. If you consider on the basis of due date, that is here you see that for first come first served basis, the average lateness is 9. For shortest processing time, the average lateness is 6.67, and for due date average lateness is 6.33, and for critical ratio average lateness is equal to 14.17. Obviously the due date sequence is the best, but SPT sequence is also not bad. This is also 6.67. It is nearer to the DD. Now if you consider average number of jobs at the work center, you see that a first come first served basis, it gives 2.93. If you consider the average number of jobs at the work center, that is shortest processing time, is 2.63, and if you consider on the basis of due that the average number of jobs at the work center is 2.68, and if you consider the critical ratio, the average number of jobs at the work center is 3.9. So in this table, if you apply, if you analyze very critically, you will see that the SPT sequence is the best. It gives the best result for average flow time, that is 18, that is minimum. It also gives the best result for average number of jobs at the work center, that is only 2.63, but to some extent the average lateness is slightly higher, that is 6.67, is slightly higher than the due date sequence, that is 6.33 days. So if you consider the overall performance for this sequencing criterion for all these ports, we must go for SPT sequence. So my dear friend, we are concluding here. So let us recap very quickly what we have discussed today. We have discussed about the concept of scheduling. We have discussed the concept of the scheduling by Hungarian method, and we have discussed the 4 criterion for scheduling, that is scheduling by FCFS, first come first serve basis. We have discussed about the SPT, shortest processing time. We have discussed on the basis of scheduling on the basis of DD and CR processes. And in the next class, we will again restart this topic, that is production planning and scheduling, and there we will discuss some very interesting scheduling techniques for different kinds of jobs, and that in that way you will have a very crystal clear ideas on these topics, that is scheduling and production planning, and that is a very important topics in management. So thank you very much. Thank you.